Good evening, students.
Good evening, sir.
Yeah, good evening. Yeah. So in the last class, we have explained the concept of dual nature formulas. Now, in the today's class, let me solve some few questions of dual nature of radiation and matter. Yeah. Now, look at the problem. First problem here. The work function of a substance is given. How much? 4 electron volt. So work function is 4 electron volt. What is the longest wavelength they are asking? Longest wavelength means maximum wavelength, that is called the threshold wavelength. Now, what is the formula actually? For the work function, the basic formula is given by hc by lambda naught, right? What is the work function formula? hc divided by lambda naught. hc by lambda naught. What is lambda naught? The threshold wavelength. Now, I have given one more formula for what? Shortcut formula. What is that? What is that? Instead of using hc by lambda naught, you can use shortcut formula no for competitive. That is 12400 by lambda naught, and this lambda naught should be in angstrom, and this final value should be in electron volt. Now, how to simplify this? Yeah, you can substitute it. No, what is the work function they have given? 4 electron volt. So 12400 by lambda naught. This is in electron volt. This electron volt and electron volt will get cancelled out. So what is lambda naught from this equation? 12400 divided by 4, right? So what is 12400 by 4?
3100.
Yeah, 3100. What is the unit?
Angstrom.
Because this wavelength should be in angstrom.
So option C is the answer.
Option C, 3100 angstrom can be taken as 310 nanometer. So for the competitive exams, you can use this formula directly for the work function. Instead of using hc by lambda, you can make use of 12400 by lambda naught. So option C is the right answer. Yes. Look at the second. Look at the second question, Appa. Photo energy is how much?
6 electron volt.
Energy. Yeah, 6 electron volt. Good. That is incident on the surface. That surface is having what work function?
So 2.1 electron volt.
Now, they are asking you to find the stopping potential. You know that the stopping potential is nothing but the kinetic energy. But the stopping potential is in volt. This kinetic energy will be in electron volt. So, according to your Einstein's energy equation, you know that total energy is equal to work function plus what? The kinetic energy. Can't you calculate what is kinetic energy from this? That is total energy minus work function. What is total energy? 6. What about work function? It is 2.1. So kinetic energy.
So 3.9.
Yeah, 3.9 electron volt. That is the kinetic energy. But you know that the stopping potential is nothing but the kinetic energy only. But don't write it in terms of electron volt. You have to write it in
Volts, sir.
and you know that the stopping potential is the minimum negative potential, right? So stopping potential should be a negative. So it should be minus 3.9 volt. So which is the right option?
So option C.
Yeah, it is an option C. Now, let us look at the next problem. Yeah, look at this, what they have given.
So wavelength. So stopping potential.
Yeah, correct. Correct. What is the incident wavelength? Lambda, no, incident wavelength.
Yes, sir, lambda.
Yeah. Stopping potential is 4.8 volt means actually this is kinetic energy is 4.8. Instead of volt, you have to write it as?
Electron volts. Sir.
Yeah. If the same surface is illuminated with a radiation of what wavelength? What
2
wavelength?
lambda. Sir. Double the lambda.
In that case, the stopping potential becomes how much?
1.6 volts.
So you can take this as kinetic energy 2. You can take this kinetic energy as kinetic energy 1. So what is kinetic energy 2?
1.6 volts. Electron volt.
Volts. Now they are expecting you to find what?
Threshold wavelengths.
That is denoted with what?
Lambda naught.
Yeah. Now, can you write the two expression? You know that the kinetic energy is given by the total energy minus the work function. So kinetic energy equals to, you know that energy is hc by lambda minus work function is hc by lambda naught. So what is kinetic energy? You can take out hc common. So 1 by lambda minus 1 by lambda naught.
Lambda naught.
So this is the basic equation. Now we are discussing for two cases, Alva.
Yes, sir.
So I will write it as kinetic energy 1 divided by kinetic energy 2. hc by hc 1 by lambda minus 1 by lambda naught. For the second case, incident wavelength is not lambda, it is
2 lambda, sir.
because it is double the wavelength.
Yes, sir.
Minus 1 by lambda naught. So you can cancel out hc and hc, right?
Yes, sir.
What is kinetic energy 1 they have given?
4.8 electron volt.
Yeah. This is 4.8. What about kinetic energy 2?
1.6 electron volts.
Yeah, 1.6. What is the LCM here?
So lambda naught minus lambda divided by lambda lambda naught. Sir.
Similarly for this?
So for this lambda naught minus 2 lambda divided by 2 lambda lambda naught. Sir.
What is 4.8 by 1.6? 3, no? 16 3s are.
Yes, sir. 16 3s.
Lambda lambda naught will get cancel. 2 goes up, right?
Yes, sir.
So 2 times of lambda naught minus 2
Minus
lambda by lambda naught minus 2 lambda. Cross multiply. 3 lambda naught minus 3
minus
2
6 lambda.
Yeah.
2 lambda naught minus 2 lambda.
Now they are expecting to find threshold wavelength. You can shift this 2 lambda naught to this side. So it becomes 3 lambda naught minus 2 lambda naught.
Lambda naught.
Minus 6 lambda to this side plus 6 lambda.
4
6
lambda,
lambda
sir.
minus 2 lambda will be
4 lambda.
So what is the threshold wavelength for this material?
4 lambda, sir.
So you can go with which option?
B.
Option B. Yeah. So this is the steps. So only the thing they have given the kinetic energy. So we are writing the kinetic energy for the two cases and just we are dividing and we are simplifying that.
Yes, sir.
Yeah. Look at this problem.
K equals to 9 electron volts, sir.
Very good, 9 electron volt. They have given E by M. E by M means charge by mass. What is the maximum velocity? Now, you know that kinetic energy, or we can write stopping potential as E times of, or you can do one thing. Yeah. What is kinetic energy? It is nothing but work, right?
Yes, sir.
Work can be taken as potential difference, that is stopping potential, into charge.
Yes, sir.
So kinetic energy can be taken as stopping potential into charge of the electron. Now kinetic energy can be taken as half mv square,
MV square. Yes, sir.
which is stopping potential into E. Now what is V squared from this equation? 2 times of Vs
Vs into
E
E.
by
E by M, sir.
Yeah. So V squared 2 into what is stopping potential Vs?
So 9 electron volt.
No, just you substitute 9 because I'm directly substituting for stopping potential.
Yes,
I'm
sir.
not substituting for
Not
kinetic
for
energy.
kinetic energy.
Yeah.
Yes.
What is E by M?
Sir, E 1.8 into 10 power 11, sir.
So what is V squared then? Multiply this two
So
times.
divided by M. Oh, they have
No.
given even the mass, sir.
E by M only they have given. No.
Yes, sir.
So this direct value. Yeah.
Root of
Do one thing. What is 2 into 1.8?
so 3.6, sir.
Yeah, 3.6. I will take that 3.6 as 36. So it becomes,
Okay, sir.
it
12,
becomes
sir.
10 power 10.
Yes, sir.
Okay. What is V then?
V equals to 6 into 18 into 10 power 5, sir.
Yeah. 6 3s are?
That is 6 is 18, sir.
Yeah. 18 into 10 power 5, or I can take this as 1.8 into 10 power
6, sir.
Yeah. So which is the right option?
So option C.
Yeah, option C. So here I'm not solving directly by considering the kinetic energy formula, because they have given one int. They have given E by M value.
Yes, sir.
So only I'm using the kinetic energy basic definition as potential into charge of the electron. So on substituting kinetic energy formula of mv squared, I'm going to get E by M format. So on substituting that, we can find easily what is the maximum velocity of the electron. What is the lowest frequency they're asking? Lowest frequency means threshold frequency, no?
Yes, sir.
Yeah. What is the work function here?
1.65 electron volt.
Yeah. What's the basic formula for work function?
Work function equals to
H nu naught.
H.
Work function divided by H. What is work function?
1.65.
You have to
electron
convert
volt.
that electron volt to joule upper. You have to multiply by 1.6 into 10 power
Minus 19.
divided by H value. 6.625 into 10 power.
So 1.6 is it the charge of an electron, sir?
Yeah, this is charge of electron volt only. To convert this electron volt to joule, you have to multiply the charge of the electron only.
Yes, sir.
So just we are converting that electron volt to joule by multiplying that 1.6 into 10 power minus
19.
Yeah.
Okay, sir.
You simplify that.
Yes, sir.
What is 1.65 into 1.6? You go with rough calculation. You can take 16 squared. It is 2.56, no, 1.6 into 1.6. You
Yes,
take
sir.
this 1.65 approximately as 1.6 only. So it will be easy for calculation. 1.6 into 1.6
2.56, sir.
by 6.6 into 10 raised to how much? Minus 34 when it comes up?
Plus 34, sir.
No. Plus 34 minus 19.
So 25.
25 or 15?
So 15, sir.
10 power minus 34 when it comes up, plus 34. So plus 34 minus 19 means?
10 power 15, sir.
Yeah. Look at the option. This is given in minus 10, which is not possible, right?
Yes, sir.
This is also not possible. This is
Yes,
also
sir.
not possible, 11. So
Option
15 is
C.
close to 10 power 14 means you can tell option.
C, sir.
Yeah. 2.5 by 1.6. If you simplify this, you will get in terms of 0 point something only into 10 raised to
If we
15.
shift the powers, we'll get
Yeah,
that.
very
answer.
good. So you will get 4 into 10 power 14 approximately.
Okay, sir.
So options is the right answer. No need of doing the complete calculations, Appa.
Yes, sir.
Yeah. This is also important. How many frequencies are there? Two different frequencies are there, right?
Yes, sir.
Yeah. The first energy is 1 electron volt. The second energy is 2.5 electron volt. For both the case, the same metal they are using, one function is 0.5. What is the ratio of the maximum kinetic energy? Now, you know that the kinetic energy is nothing but the total energy minus work
Minus work
function.
function, sir.
So what is the ratio of kinetic energy? That is kinetic energy 1 by
1
kinetic
by
energy 2. E1 minus 5 divided by.
E2 minus 5.
Yeah. What is E1? 1 minus 0.5. E2 is 2.5 minus 0.5. 1 minus 0.5 is 0.5.
0.5
This is 2.
and 1. 2, sir.
0.5 can be taken as 1 by 2, right?
Yes, sir.
1 by 2
1
by
by
2
2.
means?
So 2 by 2.
Not 2 by 2. 0.5 is 1 by 2. 1 by 2 by 2 means 1 by 4, no?
Yes, sir.
This 0.5 can be taken as 1 by 2 off by 2. So this 1 by 4, this 2 comes here itself.
Yes, sir.
So ratio should be 1 is to
4.
4.
Option B, sir.
So option B correct. Look at this form. Photoelectric emission is observed from the metallic surface of two frequencies. One is nu1, the another one is nu2. Clearly, they are telling that the first frequency is more. The maximum value of the kinetic energy of the two cases are in the ratio 1 is to k. They are asking you to find the threshold frequency. What is threshold frequency? Nu naught. This is question mark. Now, you know that the kinetic energy ratio they have given. Kinetic energy 1 by kinetic energy 2. That is 1 by k. What is kinetic energy? What's the formula for kinetic energy? Total energy minus work
Work
function.
function.
This is
E2
E2
minus
minus pi.
pi.
1 by k. What is E1? H into nu1, right?
Yes, sir.
Work function is h nu naught. E2 is h nu2. Work function
Minus
is
H
h
mu
nu
naught.
1 by k. You can take out H common in both numerator and denominator.
Yes, sir.
So nu1 minus nu naught
Divided by
by
mu2 minus mu naught.
minus nu naught equals to 1 by
1
k.
by k. Sir, H gets cancelled, sir.
Which one?
Sir, H gets cancelled, sir.
Yeah, H will get cancelled. No, after taking both the numerator and denominator,
Yes, sir.
H will get cancelled. Now, by doing the cross multiplication, you can find what is the threshold frequency mu naught.
Sir, k mu1 minus mu naught divided by mu naught minus
right?
mu2 minus. Yes, sir.
Which is nu2 minus mu naught.
Mu naught.
Or k nu1 minus nu2 equals to k nu naught.
K
If I
mu
choose
naught
this term to this side, becomes plus.
minus
Minus nu naught. So if I k nu1 minus nu2, what is the common term in the RHS?
some mu naught.
So
K minus 1.
What is nu naught? K nu1
K
minus
mu1 minus mu2 divided by mu naught. K minus 1.
So you can go with option B.
Yes, sir.
Yeah. Yes. What's the light of frequency they have given? 8 into 10 power 15. Work function is given 6.125 electron volt. What is the maximum kinetic energy of the emitted electrons? Yeah. You know that the kinetic energy can be taken as the total energy minus the work function. Anyway, work function is given, but they have not given the energy. So you have to find the energy first to find the kinetic energy. So what is energy formula? E is equal to H nu naught. What is H value? 6.625
Into 10 power minus 34.
minus 34. What about nu naught? 8 into 10 power 15. If I calculate this as it is, I will get the unit of energy in terms of joule. This I will get in terms of joule. But I want this in electron volt because work function is expressed in electron volt. And also the options are also in electron volt. So it is better to keep the total energy in electron volt only. So this is actually in joule. To convert from joule to electron volt, I should divide this value by what?
1.6. 1.6 into 10 power minus 19.
Yeah. Now if you simplify this, you will get in terms of electron volt. After substituting this energy over here, you can find what is the kinetic energy. So go with a rough calculation. What is minus 34 plus 15? Minus 34 plus 15.
Minus 19, sir.
That minus 19 is there in the denominator, so it will get cancelled, right?
Yes, sir.
So this is 8 and this is 1.6. So I can tell 8 ones are
0.2, sir.
0.2. What is 0.2? 1 by 5, right?
Yes, sir.
So one in the denominator, if I write that 0.2 as 1 by 5, that 5 goes to numerator.
Yes, sir. Into 5.
Yeah. So 6.6 here, you have to multiply by what?
5, sir.
5. 6.6 into 5 means approximately it is 33, right?
Yes, sir.
Because it is more than 30, less than 35.
Yes, sir.
So it is 33 electron volt. So after getting the energy, I think we can find the kinetic energy easily. That is 33 minus the work function 6 point something. So approximately 33 minus 6.
27 electron volt.
So you can go with option.
C, sir.
Yeah, option C is the right answer. There is a photocell that is receiving the light from a distance of 1 meter. Same source is going to be placed at a distance of 2 meter. Then ejected electron will have what? Ejected electron will be having what? We can discuss that in terms of number or whatever you want. You know that one of the property, intensity is directly proportional to the number of electrons. Intensity is directly proportional to the photoelectric current. Photoelectric current depends on number of electrons. So please remember, intensity is going to be directly proportional to the number of electrons. If you increase more and more intensity, the number of electrons constitute will be more. Correct, no?
Yes, sir.
And also remember, the intensity is going to obey inverse square law. So intensity is obey inverse square law means it is inversely proportional to the square of the distance. That means from the source, if you move away from the source, the intensity of that light which is coming out from the source will decreases. So intensity is inversely proportional to the square of the distance. So intensity is directly proportional to the number of electrons. So number of electrons and distance are inversely proportional. So what is N1 by N2? It will be ulta, D2 by D1 whole square. N1 by N2 is equal to D2 by D1 whole square. So this clearly tells N1 by N2 equals to, what is D2? Second distance is 2 meter. First distance is 1 meter.
2 by 1.
So 2 by 1 whole square. So 2 by 1 whole square means 4.
4, sir.
N1 by N2 is 4. Or I can say N2 will be N1 by 4.
Yes, sir.
So if N2 is N1 by 4, I can tell the number of electrons will become 1 by 4th in the number.
Yes, sir.
N1 by 4. So the number of electrons which is coming out of the metal will become 1/4 of the initial one if the distance is doubled. Initially the distance is 1 meter. Now they are keeping at 2 meter. So the distance is doubled. So if the distance is double, the number of electron reduces to 1/4. Here the concept is intensity is directly proportional to the number of electrons. That is one concept. And you know that the intensity obeys inverse square law. So intensity is directly proportional to the square of the distance. So option D. Yeah. Can you answer to this question, Appa? Yellow light is incident on a surface. No electrons are emitted. For yellow color, no electrons are emitted. If you give green light, for green color, the electron is emitting. They're asking If I use red color, what will happen? For red color, will electron will come or not? Simple question, basic question. You know the spectrum is Vibgaya.
Yes, sir.
In this Vibgaya, you know that the wavelength will be increasing.
Yes, sir.
Now, if I use which color? Yellow color. For yellow color, electron is emitting or what? No.
No, sir. It's not emitting.
For green color?
It's emitting, sir.
No, which color I'm using?
Sir, red.
Yeah. See, look at the concept. For yellow color, only the electron is not emitting. If I still increase the wavelength, the red color also will not emit the electron, right?
Yes, sir. It won't emit.
Because you know that the threshold wavelength meaning. Threshold wavelength is the maximum wavelength up to which the electron can emit. If you go beyond that, threshold wavelength, electron will not emit out. So for green color, electron is emitting, but for yellow color, electron is not emitting means the wavelength of yellow color has crossed the threshold.
Yes, sir.
If yellow color itself has crossed the threshold wavelength means obviously red color has to cross the threshold wavelength because wavelength of red color is more than the wavelength of yellow.
Yes, sir.
So definitely you can say that for red color, the electron is not possible to emit out. So no electrons are emitted. No electrons are emitted here.
Yes, sir.
Okay. Yeah. Look at the next question. Look at this next question. Metal is illuminated by the two wavelengths. First wavelength is lambda 1. Second wavelength is lambda 2. One is 400 nanometer. The next one is 250 nanometer. What are the maximum velocities we got? One is V, the another one is 2V, V2, that is 2V. Now they are expecting you to find the work function of the metal. Before calculating this problem, please have a look on the options. In the options, they are keeping HC as it is. They are not substituting the values for H and C. Now, can you tell me the equation which is going to be satisfied for this case? You know that the kinetic energy is what?
Sir, E minus 5, sir.
5. Now, can we go with the two cases like this? Half m v1 squared. I am substituting for kinetic energy upper.
Yes, sir. Half m
By
v2
half
square.
m v2 square. Equals
Half m gets cancelled.
Yeah. Now, can you take energy minus 5? E1 minus 5 by
E2
E2
minus 5.
minus 5. So half m will get cancelled out. What is V1 by V2 whole square?
250.
Look at this. V by 2V whole square, right?
Yes, sir.
E1 minus 5 by E2 minus 5. B and B will get cancelled out. What is 1 by 2 whole square?
1 by 4.
Yeah. E1 minus 5 by E2 minus 5. If I go with the cross multiplication, E2 minus 5 is equal to 4 times of E1 minus 4 5.
Yes, sir.
Or I can tell 3 5 is equal to 4E1 minus E2.
Minus E2.
Yeah.
Yes.
3 5 is equal to 4. E1 is HC by lambda 1. What is lambda 1?
400 into
Yeah.
10 power minus 9.
E2 is HC by
HC by
lambda 2.
250 into 10 power minus 2.
Yeah. Can you tell me the common term?
Sir, HC.
Very good. Into. What is 4 by 4?
1, sir.
Into. Shall I write it as 10 power 7?
Yes, sir.
Because I've taken
Power
these
shift.
2 zeros.
Yes, sir.
Minus. Here HC is common. Here if I shift this 250 as 2.5, I will get 10 power 7 only, no?
Yes, sir.
What is 1 divided by 2.5? One divided by
So
2.5
0.4.
is 0.4, no?
Yes, sir.
Yeah. What is 5 from this equation then?
So HC by 3 into
Ah,
0.6 into 10 power 7, sir.
yeah. What is 0.6 by 3?
So 0.2.
So 0.2.
Option A, sir.
0.2. Yeah, very good. Very good. 0.2 HC into 10 power 7. Or you can take this as 2 times of HC
Into
into
10
10
power
power
6
6 joule.
joules.
So by looking this number itself, you can guess
Yes,
only option A is having the number 2. So definitely that is going to be the answer out.
yes, sir.
Yeah. I think you can manage this. What is the work function of the metals A and B?
So 1:2.
So work
They've
function
given the
1
ratio.
by work function 2, 1:2. What is the incident frequencies?
So F and 2F.
Nu1 by nu2. F divided by 2F means
1 by
1
2.
by 2. Now they are expecting to find the ratio of
Kinetic energies.
maximum kinetic energy of the photoelectrons emitted. Yeah. Now, can you tell me what is the kinetic energy for the first material divided by the kinetic energy of the second material?
So E1 minus pi divided by E2 minus pi.
Yeah, correct. Total energy minus work function. total energy minus work function. E1 minus phi1 by E2 minus phi2.
Yes, sir.
Yeah. If mu1 by mu2 is 1 by 2, can I take E1 by E2 as 1 by 2? Because
Yes, sir.
energy is directly proportional to the frequency, isn't it?
Yes, sir. Sorry.
Yeah. So how can you go with this? Even energy becomes off, work function becomes off. Clearly, this two equation tells that kinetic energy is directly proportional to energy minus the work function.
Yes, sir.
If both this energy as well as function is changing by a factor of 1 by 2 means kinetic energy should also change by what factor?
1 by 2.
1 by 2 factor. Don't try to calculate mathematically. It goes with a very big steps, big number of steps.
Yes,
Since
sir. It
kinetic
becomes
energy is
0 by 2.
directly, yeah, kinetic energy is directly proportional to the total energy minus work function. So you can take the ratio as 1 by 2. If you are going with the exact calculation, then you have to go with equations. You know that. Two metals, no, they have defined. You write it as energy for the A, work function of A plus kinetic energy of A. What is total energy of A? For A, the frequency is h nu 1. Work function is, you can keep as it is for A plus Ka. What about second case? H
H mu 2.
nu 2 equals to, what happens to work
5
function?
B.
Phi b, yeah. Plus what?
KB.
Kb, kinetic energy of this two. But what is the incident frequency for the first material? They have given in the bracket. F is the greater than the threshold frequency of A. So this new one can be taken as HF. Phi A plus Ka. But second frequency becomes 2F. H into 2F, which will be phi B plus Kb. If I take the ratio, even HF and HF will get cancelled out, even still it will become 1 by 2, right?
Yes, sir. 1 by
So
2.
even 1 by 2 is phi A plus Ka divided by phi B plus
KB, sir.
Kb. So this is one equation. If you simplify this equation with another one, that is here where it is work function. Yeah, work function phi 1 by phi 2 is 1 by 2. So you can take this as A and you can take this as B. On cross multiplication, you will get phi B is equal to 2 times of phi A,
2.
isn't it?
Yes, sir.
You can substitute that phi B here as 2 times of phi A.
Then pi A get cancels.
Yeah. So you will get 1 by 2 phi A
Equals
plus Ka divided by phi B can be
2
taken as 2
phi B
times of phi A plus
plus KB.
Kb. Do the cross multiplication. 2 phi A plus Kb is equal to, you do the cross multiplication here.
2 phi
2 phi
A
A
plus 2
plus
Ka
2 Ka. Very good. 2 phi A, 2 phi A.
gets cancelled.
So what is Ka by Kb from this? Kb is 2 times of Ka, right?
Yes, sir.
So what is Ka by Kb for this?
So 1 by 2.
So the kinetic energy will become 1:2 ratio. So that is
Yes, sir.
option B.
Yes, sir.
You'll get the same thing only. But
Yes.
instead of guessing this, if you are solving this equation, you'll get the same answer. For
Yes, sir.
competitive, I think better, you can tell directly with the mathematics. Since kinetic energy is directly proportional to total energy minus phi, since both energy and phi are reduced by half, even kinetic energy also will reduce us by how much?
Half, sir.
So this is the way how we are going to get the equations for the kinetic energies. You got these problems?
Yes, sir.
Okay, I will stop at this stage. In the next class, I'll continue and I will try to finish off this chapter up in the next session. Okay.
Okay, sir.
Yeah.
Thank you, sir.
Thank you. Yeah.